Hokie dokie. In this problem, we are given a differential equation. And the goal is to identify what y is. And so, in some form or another, we're going to find an antiderivative, tack on a plus c, and then use the initial condition to solve for said c value. So, what's the difference here? The first step is the difference. The first step is that we want to first get y prime on this side by itself, on the left side of this given equation. How do we do that? Well, if we have e to the negative 5t, we essentially want to divide by e to the negative 5t. Another way of saying that same thing is instead of dividing by e to the negative 5t, we multiply by e to the positive 5t on both sides. In doing so, on the left side, the idea is like when you have the same base values or terms and then different exponents, you add their exponents. And so e to the 5t times e to the negative 5t is e to the 5t minus 5t, which is e to the 0, which is 1. So that's why they cancel each other out, leaving us with just y prime is equal to, and now we are distributing e to the 5t to both terms here. Again, we add their exponents when we multiply the two e terms. So we have the negative, we have e, and then 1t plus 5t is 6t. So that was adding this t and this 5t. And then we distribute the e to the 5t to the minus 4e to the 6t plus 5t is 11t. So this is our y prime. Now we find the antiderivative. That would be just y of t. So with e terms, the nice thing is the e terms will always stay the same. The negative stays the same. But then we always divide by the coefficient in front of the t within the exponent. And so it's sort of like using u substitution, really bypassing u substitution. The idea is that we're dividing by 6 so that if we took the derivative of this, it would, simplify to what we had up there because of the chain rule. The derivative of 6t is 6. So if we took the derivative of this, we'd eventually bring out a 6 in front of the e term. So that's why we divide by 6 to cancel the 6's, leaving us with just negative e to the 6t. So we can just sort of take for granted that procedure. And so if we apply it here, keep the minus 4, keep the same e to the 11t, and just divide by 11. We tack on plus c, and now our objective is to solve for c by using the initial condition. When t is 0, the y is negative 35 over 66. So let's work out this and see what happens. They're saying the y is negative 35 over 66, very specific. And then if we plug in t equals 0, we'll have negative e to the 6 times 0, which is just negative e to the 0, over 6, minus 4 over 11, e to the 11 times 0, which is 0, and then plus c. So then e to the 0's are just 1. And so over here, 4 times 1 is just the 4. So we have this and this. So adding 1/6 and 4 over 11 to the left side, we will calculate our c. So we could convert this all by hand, which I might do just to demonstrate once, or of course you could use a calculator. So negative 35 over 66 plus, how do we get 66 here? We multiply 6 by 11. And so multiplying by 11, we get 66. And so multiplying the top by 11, we get 11. Now, 11, we multiply by 6 to get 66. Therefore, we multiply the top by 6. So we get 24. And so coincidentally, negative 35 plus 11 plus 24 is 35, and everything has a denominator of 66. Regardless, we have 0 on top, therefore C is 0. And if I'm not mistaken, I want to say the C will always work out to 0. Like, they always construct it and present the problem so that C will always, or should always, work out to 0. So I believe once you find the antiderivatives, you're actually done, I think, at that point. So you can almost ignore the initial condition part and really just focus on what's the antiderivative of these two terms. And that should be it. All right, let's go ahead and do a couple more examples. This one that does not have E as a part of, the process. So just applying kind of similar methods, actually. On both sides of the equation, we can start by multiplying by t to the negative 4. Also the same thing as dividing by t to the 4th. So whichever you prefer, use whatever you want. When we multiply by t to the negative 4, it cancels with t to the 4, leaving us with just y prime. And then 5t to the first times t to the negative 4, we can still apply the exponent rule. We add the exponents. 1 minus 4 is negative 3. So 5t to the negative 3, or 5 over t to the third. I will say it might help us out to keep it like this when we're taking the antiderivative. So for the next one, we have negative 6. We're distributing this t to the negative 4 here. So negative 6 will stay. And then the t is on the bottom. So if we wanted to, we could write it like this, but that's pretty weird looking. So I might suggest rewriting negative 6 times t to the negative 1. Therefore, if we have negative 6t to the negative 1 being multiplied by t to the negative 4th, and we're combining these two t's, we add their exponents still. So negative 1 plus negative 4 is negative 5. And now we find their antiderivatives, leaving the coefficients, adding 1 to the exponent, and dividing by whatever that new exponent is. Negative 6, t to the negative 5 plus 1 is negative 4, dividing by negative 4. And we mentioned in the last one, we would have plus c, but hopefully it'll work out every single time that the c will be 0. So let's ignore that and see what happens. So we have, for the numbers here, we have negative 5 halves. Right away, that might tell us what our answer is. So let's work out the rest though. Rewriting t to the negative 2 in the denominator as t to the positive 2, and then negative 6 over negative 4 is a positive, and then 6 over 4 is 3 over 2, and then t to the negative 4th is equivalent to t to the positive 4 on the denominator, in the denominator. So which one has a 3 over 2? Which one has a negative 5 over 2? And as long as the t terms match up, we're in business. All right. So B is our answer here. Let's go ahead and do one more example here. So let's do this as fast as possible. We have e to the negative 3t, so we distribute an e to the 3t across the whole equation. We have y prime equals negative e to the negative 4t plus 3t is negative t minus 6, and then 4 plus 3 gives us e to the 7t. Antiderivative, with e terms it's the same, but we divide by the coefficient of the t term, which is negative 1, since it's negative t. And then minus 6e to the 7t divided by 7. So really the only thing that we have to simplify is likely the negative e over negative 1. We can just make that positive e. So we're looking for, looks like option D. And again, we can ignore the whole plus c in the initial condition because it seems to always work out that when you solve for c, it just equals 0. Therefore, it is no longer there. I hope this helps. If you have any questions on these problems or how to rewrite any of these to get them in terms of just y prime equals something, let me know. Yeah, all right. Just scroll through these here one more time. All right.